Hello everyone, I am Anil Bharate from Department of Computer Science and Engineering, BLDS CET Vijaypur. In this video, I am going to explain the graphs. Now we will see some definitions of graphs and few other definitions related to graph. First, let us see what is graph. Graph is unordered pair of V and E, where E is set of vertices and E is set of edges. And there is a difference between directed graph and graph. So in case of graph, it is undirected. It means that there are no directions. Say A, B, C, D. These are the four vertices. Then there is a edge between A and B, but there is no direction. It means that this edge is from A to B as well as from B to A. But in case of directed edges, we have seen that there was a direction from either A to B or B to A. But in graph, normal graph, there is no direction. Well, now next is null graph. Null graph is a graph which has no edges. See, it has three vertices A, B, C, but we do not have edges in this graph. So such graph is called as null graph. Now trivial graph, a graph which is null as well as a single vertex. Such graph is called as trivial graph. Now finite graph, it means that in a graph number of vertices as well as edges are finite. And the next definition is order of graph. Now this order is nothing but number of edges, or sorry, number of vertices in a graph. Say for example, if this is a graph A, B, C, D, then order of this graph is equal to 4 because there are 4 vertices. Next, sixth one is size of a graph is nothing but number of edges in a graph. Now if I want to have size of this graph, then it will be 1, 2, 3, 4. There are 4 edges, so size is 4. Remember, number of vertices is nothing but order of a graph and number of edges is nothing but size of a graph. Then we have end vertices. Now if you consider this graph, every edge has its end vertices. Say for example, in this case E1 has two end vertices, V1 and V2. So a edge joining two vertices are called as end vertices. Okay. Now loop is nothing but, in this case, this is the loop. It is starting from, this edge is starting from V3 and it ends at V3 itself. I am talking about E4. So E4 here is a loop. Okay. Then multiple edges. Now if you consider again this graph, between V1 and V4 there are two edges, E6 and E5. These are the two edges between V1 and V2. So we can say these two edges as multiple edges because these two edges have common end vertices. Okay. Now simple graph. Say a graph which has no loops as well as no multiple edges is called as simple graph. Now this is simple graph because it has no multiple edges as well as no loop. If I make this, or if I have one more edge of this kind, then this is not a simple graph because it has multiple edges. So basically a graph which has no loops as well as no multiple edges is called as simple graph. Then multigraph. Next definition is multigraphs. The graph which has multiple edges but no loops. Now this is multigraph. But if I have this loop here, then it will not be a multigraph. So multigraph is a graph which has multiple edges but no loops. Now general graph. The definition of general graph is a graph which has either loops or multiple edges or both. Such graphs are called as general graphs. Now incidence. Now if I have one edge E1, V1 and V2. Now we call E1 is incident on V1 as well as V2. So E1 is going to, or its end vertex is V1 and V2. So we say that edge E incident on V1 and V2. Now adjacent edges. Now if I consider this graph, say A, B, C, D. Now edges E1 and E2 are adjacent because they are incident on the same or common vertex. Okay. Now see, this E1 has incident as this is C, as well as E2 has incident as C. So they both have common incident. So we call E1 and E2 as adjacent edges. And these adjacent edges are not parallel to each other. Okay. Now next is important, complete graph. A graph in which there is a edge between every vertex and every other vertex. Say for example, I have three vertices, one or A, B, C. Now there must be edge between A to all remaining vertices. Say A to B and A to C. Yes. Now from B again there should be edge to all the remaining vertices. Say from B to A already we have, then B to C, and from C again A and C. So this is complete graph. Okay, because it has, I mean, all vertices are connected to each other, and we represent this as or denote it by K3 because it has three vertices and it is a complete graph. So complete graph is denoted by Kn, where n is number of vertices in that complete graph. So this is K4. You may be asked to draw K4. If they ask you to draw K4, it means that you should draw a graph, complete graph, which has four vertices. Already I have drawn here, A, B, C, D. From A, there are three different edges to three different vertices. Again, if you observe, every edge is, I mean, every vertex is connected to every other vertex in the graph. Okay, so such graph is called as complete graph, and it is denoted by K4 because there are four vertices in this complete graph. Now we have bipartite graph. Now this bipartite graph is nothing but, see, there will be two sets of vertices. Generally in graph we have only one set of vertices. Say V is ABC, comma PQRS. This is the complete, I mean, set of vertices. Now again there will be two subsets in this, that is V1 and V2, whereas V1 is ABC and V2 is PQRS. Now on what basis we have made these two is, see, there is no edge between A to B or B to C and A to C. See here. So this is one set. These three altogether they are one set because there is no edge between A to B and B to C. Even if you observe for PQRS, there is no edge between them. So this is another group, second group. So we have two groups or two subsets of vertices. So what we can say is, not subsets actually, this is union of the main vertex set is union of this V1 and V2, and each or the edges from one set are joining to another. So I can draw one more graph, bipartite graph, so that it will be clear. Now say A, B, P, Q, R. Now I can make two groups, A, B one side and P, Q, R another side, so that these wedges will be, yes. Now I can say this as bipartite graph because we can make two groups of vertices. This is one group and another PQR. Such graphs are called as bipartite graph. Now complete bipartite graph. Now say we have three vertices in first group, then four vertices in next group. That is V1 has three vertices and V2 has four vertices, let us say. So this is A, B, C and P, Q, R, S. Okay. Now there are two groups, so there should be edge between every vertices of this V1 and every vertices of V2. Say A must be connected to all the vertices of next. Yes. Then again same B. B should have edge with, or it should be connected to all the vertices of another group. Yes. Now even C. C to P, C to Q, C to R, C to S. Now this is complete bipartite graph and it is denoted by KRS. Okay. Where R indicates number of vertices in first group. This indicates, S indicates number of vertices in next group. Okay. Well, now uh, a complete graph with n vertices has 1 by 2 into n minus 1 edges. Say if you are given K3, you may be asked how many edges will be there in K3. So let us apply this formula. 1 by 2, what is n? N is 3 here. 3 into 3 minus 1. So it will be 1 by 2 into 3 into 2. So this 2 get cancelled and 3 will be remaining. Let us draw K3 graph. What is K3? Complete graph with 3 vertices. Okay. 1, 2, 3 edges are there, and by using that formula also we have got the same. So remember this, if a graph is complete graph and it has n vertices, then there will be 1 by 2 into n minus 1 edges. Okay. Similarly, in a complete bipartite graph, KRS, there will be R plus S vertices. Okay. And R into S edges. So you can calculate easily number of vertices as well as number of edges in complete graph as well as in complete bipartite graph. Thank you.